Hello and welcome to another Tech Campus Coffee live webinar. This is an opportunity for you to learn about career paths at Tech directly from professionals in your field.
We'll be speaking to technical representatives from a variety of fields at Tech, and they'll share why they enjoy what they do.
Participants also have a chance to directly ask speakers and recruiters questions and get a good understanding of why Tech is a great place to work, as well as where your strengths, talents, and learning opportunities lie. But yeah, so our first guest is Wes Katura. The Miltech superintendent at Highland Valley Copper, just outside of Kamloops. He's got a mining degree from UBC. And our second guest is Laura Wayland. She's a process EIT at Line Creek, and she's got a chemical engineering degree from the University of Saskatchewan. So maybe to get us started, let's maybe we'll start off some simple question. Maybe Laura, what do you do as a chemical engineer?
I'm a process engineer at the wash plant at Line Creek. So there's always a lot of things going on, and not every day is the same. So I guess to simplify and summarize, what I do is very much day-to-day support to operations. When something goes wonky in the plant, we come in and night shift wasn't running very well. We find out what the problem is and we mitigate it. That's a huge part of my job. Obviously, another huge continuous improvement and optimization. A lot of different projects going on with that, and then any ongoing capital projects that I'm working on. So we've got at Line Creek, we've got about 4 to 5 products that we're producing on a regular basis. And basically we've got the way to simplify the wash plant is we've got a coarse and a fine circuit in our plant, where we basically separate the raw material by size. And I guess a huge focus of my job since about last year has been optimizing our flotation circuit. So flotation is basically a separation process that's based on the hydrophobicity of coal, and that it basically doesn't like to attach to water. And the flotation circuit is part of our overall fine circuit. So we consider anything that's smaller than 0.3 millimeters in particle size part of our fine circuit. So flotation significantly contributes to our plant yield. So anything that we pull out of there is part of our clean coal. And I guess the way the plant is running and on a regular basis, and the product qualities that we're looking for all our different products are moisture content and ash content. And ash is basically the inorganic material that we're trying to pull out from the clean coal and remove it. So flotation is part of that. And basically the way flotation works is you induce air into a flotation cell. You've got your slurry feed coming in, and the biggest parameters that are really affecting it are reagents, and that's pretty much the main part in the wash plant that's really related to chemical engineering. We've got a frother, which is MIBC in flotation, and that's basically stabilizing the froth. So as you've got air coming into flotation, it creates these air bubbles, and the MIBC stabilizes them. And the little fine coal particles are attaching to those air bubbles, and they're floating basically. So anything that floats in flotation is part of our product. So that was a huge focus of my job, and still is. Flotation is very manually operated even now. We've implemented a few things that are working towards automating the process. We've automated the air addition on one of our banks, so that was a huge step, and that significantly improved our yield on that bank specifically, because basically you're getting tighter control on your air, and you're basically you're moving towards steady state. So as soon as you move steady state in any process, you're losing yield and efficiency. So that's just one example of what I've been working on and still am. One of my capital projects that I'm working on is actually implementing online analyzers on some of our coal streams. So one specifically is an online ash analyzer. So as the raw material from the mine is coming in, once this is installed, so we're still in the process of it, and calibrated and running, we'll be able to see real time what the dilution is in our raw feed. So that's great. The site's pretty excited about that. It'll really allow us to better control our plant and react to the feed that we have coming in. I guess that's a super quick overview. There's a lot of things going on every day, and it's not the same every day, which is one of the things I love about my job.
Well, speaking of that, so this great summary, you mentioned something at the beginning, that sometimes things go wonky and you react to that and do some troubleshooting, I guess. Well, can you give us an example of sort of what can go wrong and how do you fix that?
There's a lot of things. I could go back to flotation. So we've got 4 different crews, right? So we've got a day crew, and then a different crew comes on for the night, and they basically switch on 12-hour shifts. So if a big part of running your plant is making sure that your operators are trained very well, and if you don't have that, then you won't necessarily get efficient operation in your plant. So if an operator is new and they don't quite understand all the processes and how they interrelate with each other, then he might be making a change. Let's say in flotation, he'll turn the frother dosage, the MIBC dosage down, and that'll destabilize your froth. So now you have a very thin froth and your air bubbles are popping at the top, and that means you're losing that coal back into flotation, and now it's going to rejects. So when we come in the morning, every morning we've got a crossover. We find out how the night shift was running. So we basically go all over a bunch of parameters, and see how the plant was running. If they tell us, okay, our MIBC dosage was, let's say, 11 cc, that already tells me we've got a certain set point of what we're expecting it to run at. And if they're saying it was this low, we're expecting 13 cc, then I can already tell you, okay, well, your flotation isn't pulling as much as it could, and now you're losing yield. So then we go in the plant and we correct this. Obviously, since it's a manual operation, you really gotta. It's a very visual thing, so you got to go out there and make sure that the froth is actually looking good. You got to know what to look for. But that's one of the examples that if something isn't going right, you basically, as a process engineer, you're really guiding operations on how the plant should be running and what you're expecting.
Great. Yeah, so that gives a little sort of snapshot of the steelmaking coal side. Maybe let's switch gears a bit here. So with Wes as a mill super on sort of with our coal plant there, what do the chemical engineers who report to you do?
Yeah, hi, good morning, everybody. I have a 30-person team, is my video not working? Can you guys see me okay?
We can see you good, yeah.
We can see you great.
So I've got a 30-person team, and I've got mineral process engineers, and the folks that could become mineral process engineers would be potentially from the chemical engineering discipline, or could be electrical engineering or mining and mineral processing, which is how I got into it. So those folks, we've got 8 of them, and 7 of them are in charge of different circuits at our plant, and then 1 is in charge of projects. The 7 that are in charge of the circuits, so we've got an owner of crushing, an owner of grinding, an owner of bulk flotation, and on and on. The responsibility that they have is to monitor the performance in their circuits and to drive improvement projects. And those improvement projects could be on improving throughput or recovery or safety, that kind of thing. They're working a lot with the operators in the circuit and the supervisors. They're working on these improvement projects, and once they've decided that there's some new equipment that needs to go in, they'll justify the expense of that new equipment, or they'll justify a change in how the circuit needs to run, and we'll update our process management system so that we can communicate that to operators and supervisors. And it's really just about driving as much revenue out of the ore that we're mining as we can, at the lowest cost that we can, as safely as we can. These pictures here, the one on the left is our bulk flotation circuit. This is a new facility that was built in 2014. You can see an operator there in the foreground. This is our rougher scavenger flotation side. So you can see there's three banks of 7 300 cubic meter flotation cells. These are huge flotation cells, and that's that facility. On the right is a cutout of our grinding circuit. So a big part of what HVC does is comminution, or breaking rocks down from about 5 to 6 inches down to the size of sand. And when you get it down to sand, now you can liberate the valuable minerals from gangue, and then recover it in bulk flotation. This large mill that's in the foreground that has the yellow gear, that's our most recent big upgrade in our plant. This was a $70 million upgrade that went in last year. It's called our D3 mill, and it debottlenecks half of our grinding circuit, our D&E grinding circuit, driving about a 6% increase in throughput and about a 2% increase in copper recovery. And then another picture here. This is a view of the mill and the mine. The mine in the sort of the center there, that's the Valley pit. We have 3 pits: Valley, Lornex, and Highmont. And you can see that there's this amphitheater type cutout on the left of that pit. So that's the west wall pushback that we're mining right now. We're quite a few benches below that now, but that's where the ore is coming from. And then on the bottom left, where you see these this Canada flag on these domes, those are the stockpiles that feed our mill, which is that building there, again on the bottom left. That's where that grinding bay is. Looks like this is an older photo, so the flotation is not there yet. But that's what the site looks like. It's a big site. Like if you look at it on Google Maps, look at a map of BC, you can pick out our site. We're about the size of Kamloops. It's a big area. There's a lot going on there. There's a lot of ground to cover.
Awesome. Thanks, Wes. So running sort of the mill there, what are some of the big challenges in your role?
It's never ending. Yeah, I manage a large group. Again, I've got the mineral process engineers. I've got a process control group, which we're looking to expand. And then I've got a couple of lab groups that report to me. But really, it's reviewing how we're doing production wise, where are we doing well, and more importantly, where are we not hitting our benchmarks, and then how can we improve so that we start hitting those benchmarks. The other aspect is driving improvements. We're always trying to do better, and we're working to advance and justify making some capital investments on various things. And then this Race 21 project has been a big focus for us. So at HVC, right now we have a machine learning model that tells us how to run our flotation circuit. And the way that has happened is that with all the data that's coming off of the various sensors in the plant, that's being fed into an algorithm that's looking for patterns in the data, finding the most optimal operating conditions that have driven the lowest losses of copper, and that's given the inputs that are recorded at the same time. And so now it's optimized this model, and it'll then tell us every 20 minutes what set points to use for the various controls that we have in the circuit, be it reagents or water addition or how we're pulling froth off of the cells. And it's been a game changer for us. So we've tied about a 2% recovery improvement to using machine learning, and that for us is worth about $30 million a year in additional revenue. It's a really exciting thing, and we're looking to essentially have our entire plant run off of machine learning algorithms or some version of that.
We've got a question from the audience here. So Kayla, if you want to take your hand down and just put your video on if you like, and we can hear your question for Wes or for Laura.
Or if you're shy, you don't need to have your worries.
Yeah, we will make you.
That's okay. Hi there. My name is Kayla, and I'm a fourth year graduating student at Queen's University. I just wanted to say thank you for sharing your current challenges and projects. And I just had a question for both of you. Basically, how did you get from where I am to where you are? So obviously for Laura, it won't be as extensive as you're an engineering training currently. But just for both of you, how you kind of progressed through your career at Teck to get to the projects that you're working on.
Great question. Who wants to go first?
Want to start, Laura?
Sure. Yeah, so I've been at Lion Creek for 3 years now. As an EIT, I'm just about to get my PN, super excited about that. I actually had a co-op at one of our other Teck coal sites here in the valley, Greenhouse. So I had that in my 3rd year of university, and that was a huge help to actually getting this job. A co-op term doesn't always seem like a huge benefit, but it really was, and like that's what everybody tells you as well. If you have the opportunity to do a co-op term, do it, because it leaves, if you're a great you can leave such a great impression on even just your supervisor and the people around you that that kind of will drive you to get a full-time job later on, especially with Teck. Like I was lucky that my supervisor at Greenhouse, he actually moved to Lion Creek, so I had even a deeper connection, so that was great. But it kind of teaches you how to work in a practical environment as well, and it really sets you up for success, because what I've been noticing is just, coming out of school, and if you've never had a practical engineering work experience, you're really kind of thrown on the cold water and getting this reality check when you could have gotten this during a co-op. Working at a real engineering job is quite different than just learning in school. So yes, there's a theory part, but you have to kind of balance the theory with the practical, and that's a huge part of that. And relationships with people is a huge part. So that's how I got here.
So Laura, before we jump to Wes, I had a question for you then, just to continue on that vein. What do you think you did to help stand out and get hired full time after your co-op work term?
And by the way, you're preaching to the choir here. Hallelujah, nice work.
I think the biggest part was just having a positive attitude, and I think that went a long way. You hear feedback from people on your own performance and how you're doing, and that's always the biggest thing that stands out. And being enthusiastic about your job and about what you're doing, being interested, right? Having a stake in improving the company and like improving production, that kind of thing. And the more you talk with people, I know engineers are stereotyped to not be good communicators, but you really have to build relationships with people. It's huge. And I mean, after a while, you get used to it. But I think the big thing is just having a positive attitude and learning from your mistakes.
Wes?
So I've been at Highland Valley for 15 years. I never thought I would be here for 15 years, but it's been such a great work environment that it's just continued that way. I'd say for you guys, the key would be to get a co-op position in the field that you're interested in. So when we are looking to hire an EIT at Highland Valley, that's what stands out on resumes, is if someone has co-op terms or just even a co-op term in a mineral processing plant, we would be interested in talking to that person. For me, I'd done a number of co-op terms, and I think that's what helped me get hired at Highland Valley as an EIT back in 2005. I progressed up to a senior engineer, again in charge of various circuits. And then probably the key for me was in 2014, I transferred to a department at HVC called Strategic Planning. And in that division, I worked with mining engineers, financial geologists, and that group's really in charge of sort of the long range planning and larger projects at Highland Valley, and it gave me a much broader view of what really drives performance at Highland Valley. And then from there, I became chief process engineer, coming back into the plant in an operational role. Did well at that, and then now I'm the technical superintendent. So I think moving around a little bit is helpful, even within one organization. But if you really want to advance fast, you probably want to move around various sites. And at Teck, you can do that. So you can move around. You can go down to South America. There are opportunities. You can go from coal to copper. We've had a number of people transfer around, and having that broad experience, really helps you progress faster. Is what I would pass on as information.
Great, thanks, Wes. Just full disclosure, we didn't tell them to talk about co-op students, just to let you know. They're doing our job here for us, but it is true. It's built in the culture at Teck, right? We've got a very strong co-op program, and it definitely funnels talent to the full-time roles, and you'll probably see that every campus coffee. Maybe next question. I think, should we switch gears to the co-op student role, Stacy? Maybe
Yeah.
Laura. What does a co-op student role look like in your department?
So I've usually got a co-op student under me, and a big part of their job is also day-to-day support for operations. And then usually we'll have, depending on the time frame of their co-op term, we'll have them work on a one or two bigger projects. So I know one of our more recent co-op students, he was part of one of our capital projects. It was a dust fencing project. So the environment is a huge aspect of the mining industry, obviously. And so as part of the coal sites, sometimes we generate dust, and this project was about installing dust fencing at our plant truck dump, where we have some of the raw coal stockpiles sitting. And depending on, what the weather is like, if it's windy, then sometimes I'll just blow that dust off if it's really dry. So he was in charge of starting from the beginning, scoping out the job, talking to vendors, getting different quotes, looking at the installation, actually having the vendor come in, basically scope out the job, and then work through the installation with it and being in charge of that. So that was one of the bigger projects we had co-op student work on. And then the other aspects are, monitoring performances of different pieces of equipment. We've got a lot of vibrating screens in our plant. The one area is in the fine circuit, and the vibrating screens there, they weren't really working optimally. So we had the co-op student, set up a baseline of the performance, figuring out the screening efficiencies with different testing and samples and that kind of thing, making recommendations for, what can we do to actually improve the performance of these, and then implementing those recommendations. And then monitoring other areas of the plant. Magnetite is a huge part of our coal sites. It's a huge part of actually being able to separate the coarse clean coal. And magnetite's expensive. So it's a huge cost reduction initiative that, if you're above budget consumption, then everybody's looking at you. And so that's monitoring our magnetite losses and troubleshooting those.
Great, that's cool. They're getting some good experience in there. Then, hey, I always tell students, a lot of them will ask me about, what do they get to do, what kind of projects, and I always say, we basically treat you like an EIT on site. You get similar projects or supporting an EIT, so it's nice to hear that coming from you as well. Phew, telling the truth. And then we also have, I mentioned at the beginning, we have obviously several operations that we hire students. We have obviously someone from steelmaking, coal today, and copper, but we also had a student here that worked at our trail operations as a student. And I think it'd be nice because they do hire a lot of chemical engineers at our trail operations. So Lauren, if you wouldn't mind turning your mic on, and if you want to tell us a little bit about your work experience at trail, how's it going?
Hi. Yeah, so
I just finished working at Trail for the past 8 months. I was there from January to, I guess, the end of the summer. And yeah, so I worked in Trail, and the plan when I got there was I was supposed to work 4 months in the head office helping with modeling. And like Trail has a metallurgical model that they have their whole process modeled in a software. So that's a really good introduction to get a feel for the facility and understand how it's connected. And the second 4 months, you're supposed to move into a plant position and work with a production engineer and get a feel for what it's like to actually work in operations. Unfortunately, because of COVID, I never got the opportunity to move into a plant because they only had essential personnel on site. So I worked in modeling and in the head office for my whole 8 months. But with that, I was able to like organize tours and get in contact with all of the different EITs working in the different plants and get tours of the facilities. So I was still able to like get on site and see how things worked, which was a really valuable experience. And working at Teck too, I found on my other co-op terms, I didn't have true chemical engineering experience versus working at Teck and at that facility. Like you're using everything you learned in school to try to solve day-to-day problems in the facilities or larger problems for like optimization problems. So I thought it was a super valuable work experience in terms of getting true chemical engineering experience.
Awesome. Thanks, Lauren. Good to hear from Trail a little bit and get an insight into what happens there, because it's definitely a complicated and really interesting facility that we have.
Yeah.
What's that? Sorry?
I was just saying it was a really cool experience.
Oh, awesome. That's great. Okay. And then we have a question here, I think, on the chat. Do you want me to just go through that, Misaki?
Yeah, fire away.
Awesome. Okay. So I don't know if you guys can see the chat, but it's a question for Laura and Wes. And what advice do you have for co-op students when working their first work term? And how can they get the most out of their position? Maybe Wes, do you want to field that one, or Laura, whoever? It doesn't matter.
I can take it. I'd say it's treat it as if it's a job interview, because it is. I mean, for us, when we have a co-op student, those are the people we would be looking to hire, because you're going to learn. Like I trust having a co-op student for 8 months. I trust my knowledge of that person and what they're going to bring to the table as a full-time employee more than a short phone interview or 30-minute sit-down interview. Like you really get to know that person. So that's what I would treat it as. And the things that we look for are, again, attitude. I'd echo what Laura was saying. Like a good attitude means a lot. Good communication skills, hard working and determination are other key ones. But probably what really allows people to shine, I think, is that communication, good attitude.
Thanks, Wes. Yeah, I often say that to students when I'm interviewing them. This would be the best 8-month job interview you'll ever have. So yeah, it's funny that you should say that, because yeah, certainly that's the way to look at it, in my opinion, as well.
Your thoughts, Laura, on the same question?
Yeah, I'm mostly agree with Wes. I mean, the attitude that you come to work with, if you're my co-op student, I see that every day, and that's going to leave an impression. If it's negative, that sticks. And I think the other big part is, showing obviously motivation, which is part of attitude, but also like work ethic. Like if I don't have to repeat myself all the time to you, if I don't have to keep basically spell things out for you, that's a great impression for me, and I can see that you can work independently, and you can actually use problem solving skills, and I don't have to show you every little step of the way. And if you come to me, with a problem, if you're already thinking of the solution, that's great.
Perfect. Yeah, being proactive and thinking like an engineer.